Hi, friends. Today I'm going to read to you Heating the Atmosphere. You may have had an experience like this one. The campfire is burned down to a bed of hot coals, perfect for toasting some marshmallows. The only stick available is about a meter long, but you go for it. You can hardly stand the heat from the coals because the stick is so short. But after a minute, the marshmallow is brown and gooey. You pop it into your mouth. Yikes! Didn't wait long enough for it to cool. This story includes a couple of intense heat experiences, but have you really stopped to think about what heat really is? What is the heat you feel coming off the coals and the heat in the marshmallow that burn your tongue? Heat equals movement. Objects in motion have energy. The faster they move, the more energy they have. Energy of motion is called kinetic energy. Matter, like nails, soda bottles, water, and air, is made of atoms and molecules. The atoms and molecules, even in steel nails and glass bottles, are in motion. In solids, the molecules vibrate back and forth. In liquids, the gas and gases, the molecules move all over the place. The faster molecules vibrate or move, the more energy they have. Molecular motion or molecular kinetic energy, and that is heat. The amount of kinetic energy in the molecules of a material determines how much heat it has. The molecules in hot materials are moving fast. The molecules in cold materials are moving slowly. Heat transfer. Heat can move or transfer from one place to another. Scientists sometimes describe heat transfer as heat flow, as though it were a liquid. Heat is not a liquid, but flow is a pretty good way to imagine its movement. Heat flows from a hotter location, more energy, to a cooler one, less energy. For example, if you add cold milk to your hot chocolate, heat flows from the hot chocolate to the cold milk. The hot chocolate cools because the heat flows away. The cold milk warms because the heat flows in. Soon, the chocolate and the milk arrive at the same temperature, and you gulp them down. Temperature and thermometers. How can you find out just how much heat is in the part of the atmosphere where you are? With a thermometer. A thermometer measures temperature. Temperature is a measure of the average kinetic energy of the molecules in a material. If a thermometer is surrounded by air, it measures the average kinetic energy of the air molecules. If it is surrounded by water, it measures the kinetic energy of the water molecules. If you hold the thermometer bulb between your fingers, the thermometer measures the average kinetic energy of the molecules on the surface of your fingers. If you stick a thermometer in a cup of cocoa under your tongue or in a freezer, it will measure the average kinetic energy of the molecules touching it in those places. How does a thermometer work? Think about an alcohol thermometer on a wall in a cold cabin. The kinetic energy in the air molecules is low. The kinetic energy in the glass and the alcohol molecules is low. The air molecules and the glass thermometer bulb have the same kinetic energy. The top of the column is alcohol is at 5 degrees Celsius. Brr, it's cold. So you turn on the heater. Pretty soon, warm air is flowing into the room. Warm air has kinetic energy, and cooler energy. The energy added to the room in the form of fast moving air molecules start as a chain of events.